Hi, I'm Brian Iverson. I'm the inventor of the Tstud. They call me the Tstud guy, but today I'm going to represent the wall assembly. So where did the BareNaked Tstud get its name? We started out with the R19 Tstud. So 2 wood members, foam core. We found out that, well, you'll see here in a second, 58% of all builders use bad insulation. So they like the foam core. Put your stud in place. You get your bad insulation in between, off you go. But we did find out that 39% of all builders either do spray foam or something else. So the BareNaked Tstud was born. So that's how we got here, okay? So that's enough of that. Okay, we're going to talk about energy efficiency and why to use the BareNaked Tstud today. So, bit of a history lesson. I got 4 of these wall assemblies. So this is the standard 2x wall assembly that I think it's 92% of all contractors in America and Canada use. 2x4, 2x6, 16 inches on center. 8% the government says actually does 24 inches on center for advanced framing. Probably, I'm going to assume that most of those are in California and probably a big grouping of the Habitat for Humanity people. Okay, 2 top plates, stud 16 inches on center, bottom plate. Okay, I don't know how many of you, so I'm going to give you the good, bad, and ugly of everything I know. Sheathing. How many times does your sheathing and your bottom plate land perfectly flat? That doesn't happen. How many times is your stud 5.5 inches wide? You're going to see here. I don't know what the percentages are. 80% or something have to be 5.5. 20% or something else. So you're supposed to just accept that. Okay, still 3 nails, in a 2x6, 2 nails in a 2x4, none of that changes. Okay, if you're trying to control air changes per hour, you caulk underneath the bottom plate to the sheathing deck, right? So this is the standard wall assembly that 92% of all builders in America use at 16, 8% use it as 24. So what you have is up to 24% is what the government says of framing members in a wall assembly. So you have 24%, this is known as a bridge. So this is the outside. If you're in Arizona, get up in the morning, you don't need a stud finder to hang pictures. You just put your hand on the wall because you can feel the sun baking through and you can feel the heat of the stud. So you have this, it's called a bridge. The R value of this is 6.8. So 6.8 versus that cavity insulation is at least a 19. And so 24% of that wall makes your whole entire assembly inefficient, especially when you start looking at what's the effective R value of your insulation. So that sun's baking through or the cold is trying to freeze your wall stud. That insulation that's right here, it's got an R value of 19, let's just call it for today. This is 6.8, that's 19. That cold or heat is trying to transfer through there, and it's affecting the ability of that insulation to actually work. It's being polluted because this cold or heat transfers laterally in the wall. So you got to get 1, 2, 3 inches away before you actually get to the temperature of the wall that you want it to be. That's what that bridge does. It's not, when you look at the effective R value of your wall, or computer programs look at your effectiveness of your wall, you can't just look at what's the R value of the insulation. You got to look at what's the ineffective R value of that transfer, that bridge area. That's what you have to do. So the BareNaked Tstud and the Tstud solves all of those challenges for you, of which I'm going to go over all that math. Okay? I hope to not bring this up again. Okay, a bit of a history lesson. Thanks to these people, Home Innovation Research Labs, they did this whole big study. Somebody told me it was 233 pages long. So not a little study. But so they did this graph. It's 2018, it was done in 2019. So who really cares if it's off a percent or two? Fiberglass bad insulation accounts for 52% of the market share. Okay, that's great. Blown in fiberglass, rock wool, cellulose, spray foam, that's either closed cell or open cell foam, and foam board insulation, which goes on the outside, our R5, R10, whatever it ends up being, goes on the outside of the structure to provide a thermal break. okay? And others, that would be like hay bales, tires. I'm not really sure what that is, but that's probably ugly. Okay, so what I did then is I said, well, that foam board goes on the outside. I want to know what's in the cavity. So being an analytical, I came up with my own program. Here's the insulation used. Here's the percentages of what that graph shows. With rigid board on the outside is 11%. I wanted to get rid of that because I only want to know what's the percent of the cavity. So I got rid of that, adjusted this accordingly, and 58% use fiberglass batt. Okay, so the rest of the 39% use blown-in fiberglass, a blown-in cellulose, blown-in mineral wool, or a spray-in closed cell or open cell foam. Okay, others, I should have thrown them out. I don't know what they are. 39%. So the BareNaked Tstud is made, for the most part, for the spray-in, blow-in world, because you don't have any way to insulate around the dowels unless you do a flash and batt. So you spray foam, closed cell foam, throughout the cavity to control air changes per hour, and then you fill in the gap. Then you stuff a batt in. Then you can do it that way. Okay, so that's a history lesson. Okay, so being a certified energy auditor, I've designed 750 structures that have been built. So I have a degree in architecture, engineering, and I'm a journeyman carpenter, finished carpenter. Okay, so this is the 5.5-inch BareNaked Tstud. So what I did is I said that the majority of builders are going to make it simple on themselves and build the wall assembly I have behind me. Okay, so this is all of the math that it takes to actually do a full-on comparison of a wall assembly. There's 100 different wall assemblies. I cannot compare to them all, okay? You change that little thing, or you do this extra or that extra, it changes the math. So I've taken the biggest averages that I could possibly find in order to calculate this out, okay? So the math I'm about to show you, this is the detail that I went through in order to calculate that out to the square inch, and I verified to the square inch. Okay, so this is online. You can go look at this, okay? So hopefully that doesn't fall. Okay. BYOW, build your own wall using the BareNaked Tstud or the Tstud. So I went through and compared several different wall assemblies on how to stop the ability of that cold and heat to transfer through all your framing members, okay? So I did a 2x4, 2x6 wall assembly framed at 16 inches on center, and according to the energy.gov and according to building scientists, according to everybody, the average framing area in a wall assembly is 24%. I've seen 28 in a manufactured housing complex. They're big. They build in California. They have seismic. Every stud is a double stud in the wall because they need the glue area. That's another subject. So what I did is I took 16.3% because if you're building super energy efficient and you're counting your studs, you're probably more apt to be in the 18-19% range, but I did 16.3. For the BareNaked Tstud, so the average house in America, average single family house, apartment, condo, townhome, you got to look at everything, okay? So the average is 2,450 square feet. That's the average size house, single family, multifamily in the United States and Canada. So it has 9-foot tall sidewalls, 4 corners because it's a box, more than likely. This takes into account 2-story houses, but 75% of them fall into this category. Okay, so that's what we used. 8 windows and doors for the Tstud and the BareNaked Tstud wall assemblies, and I used a 2x6 for the top plate and bottom plate. Okay, so there's 18.8% framing area, deploys 95.35% complete thermal break, so continuous insulation through your wall assembly, 95. That's what all this math is built on. I can tell you I know how to make it better, so I'm going to show you that as well. but you have to stop that cold and that heat from being able to connect from the outside to the inside, affecting your utility bill. That's what this is about. So if you're a builder, you're trying to build efficient. Well, we know at our level, we know how to build houses that should be able to, instead of having big, huge ductwork running to every single room, we know that that can all run through 1, 2, 3 inch PVC pipe, because that's how energy efficient you make them. Okay, so a 2x4 down here, fiberglass bat insulation, obviously not very good, and there's getting to be less and less builders building this way. Average R value 14.2, and so to get to the U value for you analytical people like me, 1 divided by the R value gives the U value. So the higher the R value, the more energy efficient. The lower the U value, the more energy efficient. Here's what, for the most part, is the standard in the country: 2x6 with an R19 fiberglass bat. So the average R value, calculated out exactly the same way I showed you. So the average R value is 19.7, and the U value is 0.051. The BareNaked Tstud with blown-in cellulose, blown-in mineral wool, or an open cell foam. They all have about a 3.7 per inch R value. So you got the R value up to 21.4, and the U value all the way down to 0.047. Okay, so that's this wall assembly that I have behind me. So that's a 95% complete thermal break throughout the whole entire thing. And that's how simple we made it to jack that average R value up that high. That's a pretty impressive jump to get from that to that. Okay, so here's the BareNaked Tstud with blown-in fiberglass bat. Okay, so this is a big chunk of the market. So the average R value of 4.18, you get the average R value in that wall assembly up to 23.7, and you're starting to tick away at that U value down to 0.042. So that's pretty efficient. The HERS score reduction, right? The lower the HERS score, the more efficient the structure. This right here is a 4 to a 7 off your score just by using a blown-in product at all, and the BareNaked Tstud or the Tstud. Okay, here's a 2x6 with an R19 fiberglass bat with continuous insulation on the outside. Average R value 24.7, and the U value 0.041, so just a little bit better than that one right there. Okay, obviously the cost of putting that R5 on the outside was quite a bit higher than doing this one. BareNaked Tstud with the blown-in fiberglass with an R5 on the outside. Okay, because it's not like we're poo-pooing the R5. We know the math. We know the energy efficiency of it. So we got the average R value up to 28.7, and we got the U value. Holy crap, we get this down to 0.035. Look at that. That's 50% better than that. Well, your utility bills are probably in half of that one. Okay, here's a BareNaked Tstud with 5 inches of closed cell foam. Closed cell foam that's got an R value of 6.7 per inch. We did this house. I don't know what they got to reduce their furnace size and air conditioning size down to. It's an architect designed house, fully stamped out by architects and engineers. But the average R value of 35, they got the U value down to 0.028. When you start getting numbers that are down this is carbon neutral. This is where it hardly takes anything in order to heat and cool that house, because the occupants inside running the shower, doing this, doing that, cooking, is just about heating the structure by itself in the north. And obviously you have to worry about cooling the structure, but I bet they got their costs, I bet they reduced their heating and cooling bill of this probably by 30%, maybe more. So in the fall, we'll go back to building the R19. And so this is just a little comparison. The R19 with the fiberglass bat, R value 25.3, which is obviously significantly better than that 19.7. And we got the U value all the way down to 0.039. That's the advantage of having that complete thermal break with the foam in the middle of it and getting an R value of 19. Okay, so this is all online and available to you. So you can see all the advantages to having that thermal break through that wall assembly by just unhooking the ability of the heat and the cold to transfer through. Okay, so here's some comparisons. The R value of a 2x4, 4.375. The R value of a 2x6, so I'm calling this 100%. So this is my standard in this little comparison. Okay, you take a R value of a BareNaked Tstud with cellulose, mineral wool, or open cell foam, 3.7. You got it all the way up to 10.55. So you're trying to make as much of that framing, that 24% or 18% for us, you're trying to make that as high of an R value as what you possibly can. That's 153% better than that 2x6. You put a closed cell spray foam in, well, here's fiberglass running here, 11.27, 164. Closed cell spray foam in there, so either you fill the whole assembly or you do a flash and bat or you fill anything inside of it, you're going to get all the way up to an R value of 15 for 295%. So what's the continuous insulation through the BareNaked Tstud wall assembly? 95%. What's the continuous insulation through the BareNaked, just the Tstud itself? That's the whole wall assembly. That's the Tstud. 91.44%. So what's the continuous insulation through any kind of a 2x? 0. So that's where all your heat transfers through. That's where your cold transfers through. The insulation's doing its job, but it's polluted. You know, it's trying to work overtime. Okay, so the advantages of doing the Tstud are they're certified to hold 3,600 pounds if you use them on a number 2 plate. They're certified to hold 5,600 pounds if you use them on LSL or LVL, so you get to use a lot less of them. So every structure built to date in the last 2.5 years are all 24 inches on center. So you can go to the how-to video where I explain all that. So, but if you build at 24 inches on center, you save 582 lineal feet, or 24% of all your framing members. You didn't make it any weaker. You just didn't need them. So, and with that, you save 2,000 fasteners. So this is a massive reduction in the carbon footprint, and you're getting yourself everything that you can possibly do to get yourself to carbon neutral. That's what you need to try to do. You know, we build 1.2 million houses, 1.5 million structures, whatever, in the United States and Canada every year. Can you imagine if we took 10% off of the utility bills, the gas and the electric costs, to be able to maintain those structures at temperature? Can you imagine how efficient that they get to be if you can stop the cold and the heat from coming through, affecting how often that furnace comes on or that air conditioner comes on? That's why we're here. That's why we exist as a company. Okay, so this is all of our technical evaluation report. What it takes to become code compliant is a whole nother subject, but so we passed. So this is wind loads 1, 2, and 3 for you analyticals. Wind loads 1, 2, and 3 runs right through right there. This is 12 inches on center, 16 inches on center, and 24. So I'm just going to show you the big stuff. So 50 mile an hour wind load, that's 50 pounds a square foot wind load is 160 mile an hour sustained. So that's, I think that's 200 miles an hour total. So that's Dade County, Florida. We're still holding 3,500 pounds out here for an 8-foot stud, and we're holding 1,040 pounds on a 9-foot stud. So all of wind loads 5. So hurricane areas right down here, we made it on the 8 and the 9-foot stud. So the 10-footer we made it, but you actually got to go to 16 inches on center. Okay, 16 inches on center, the 10-foot stud right here. That's for wind loads 1, 2, and 3. So in wind loads 1, 2, and 3, a 12-footer still holds 640 pounds. So we got 12 inches on center. Obviously, we annihilate all the math. Okay, so that same form that I had, that's written up there. So this is the back side of our brochure. This is the front side of the brochure. So pretty, BareNaked. Okay, so that's what that looks like. I'll leave that up for advertising. Okay, so here's option number 1 is to build the old-fashioned way, right? Okay, that's what you're going to do. Okay, so you want to start controlling that heat and the cold come through. Option number 1, still go ahead and use your 2x6s for your top plate and bottom plate. No problem. Caulk along, control your air changes per hour. And obviously you can see here, the BareNaked Tstud's 5.5, and my 2x6 I bought from the local hardware store is 5 3/8. Okay, this happens all the time. Okay, so that's, for us, that's option number 1. option number 2, okay, so a little bit more work for the builder, is using the BareNaked Tstud for the bottom plate. Now, why do you want to do that? Because you can come in there with your spray foam can. You're probably spray foaming in the rim to control air changes per hour anyway. So just have the guy come upstairs and fill in the bottom plate. Crap, if you only did that, you completely sealed this down and you got rid of all the caulking. And I don't know how many times, I think I said this before, this is hardly ever laying flat on top of that deck sheathing anyway. So when you spray foam through there, that's a complete seal. Never goes anywhere. And okay, so this is using a BareNaked Tstud for the top plate. This is super strong. So, but for fire, you know, maybe you don't have all of the same things going for you. Maybe you want to use the majority of this with cellulose or blown-in fiberglass or open cell foam. If you put the 2x6 on the top, then you've met your fire requirements. Obviously, if you have a fire in the wall assembly and you burnt out the top plate, or you burnt out whatever it is that you have at the top, I'll show you next one. If this allows to burn through, the air that's in your attic will fuel the fire coming down. So you have to have a fire block, a fire stop, okay? So spray foam in this. You don't have to. You can still caulk underneath and then insulate the whole cavity with whatever you want, okay? So this is option number 2. This is pretty fun, okay? So if you don't want to use a closed cell foam out on the job, you don't have to. You can still do everything here with your insulation. Just do a 2x6 for your top plate. Okay, option number 3. Okay, obviously this is what I like. Okay, so option number 1, you got a 4.6% bridge area, so your continuous insulation was 95%. Number 2 that I just showed you, you got your continuous insulation up to 98%, so you still had a bridge of 2%. If you use the T-stud for the bottom plate, BareNaked Tstud for the top plate, you have to put closed cell foam in the top. You have to fill this in, because that's a type 1 foam. Sprayed in the field, doesn't burn, chars, burns less as fast as the 2x material. So lumber is a class C, burns up like burns. Type 1 foam is a class A type 1 foam. Okay, so this has to be sprayed in with a type 1 foam if you go this route. Okay, you controlled your air changes per hour at the top. You controlled your air changes per hour at the bottom. This is a 99.2% continuous insulation through the wall assembly. So we have the dowel area makes up 0.8%. So that's a pretty sexy route to go. So if you compare that, you can see how significantly more energy efficient this is compared to the lowly way that we used to do it. Okay, so that's what I got to tell you. Sorry that took so long. I'm Brian Iverson. I'm the Tstud guy. And I look forward to having you use our BareNaked Tstuds and the R19 in the fall.